Hi there, I'm Kevin Yank, the Principal Architect for Front-End Engineering at CultureAmp, and this is a talk I gave at the Melbourne JavaScript meetup on the 13th of August 2025, How to Build an Agent in JavaScript. And you can see on my title slide here that I'm also crediting Thorsten Ball, because in the spirit of AI technology, I borrowed Thorsten's blog post without permission in order to help me generate this talk. I hope he doesn't mind. This is the blog post in question, How to Build an Agent, or The Emperor Has No Clothes. It's on the AMP blog. AMP is a agentic coding tool from SourceGraph. And this blog post came to my attention at the Web Directions Code Leaders Conference in Melbourne in early 2025, where speaker Jeffrey Huntley, who had recently gone to work at AMP, mentioned this as, for his money, the blog post of the year. He said if you were trying to get your head around or come to grips with this new LLM-powered coding tool landscape, that this was the blog post to read. And when we talk about those tools, we're talking about these things. This is the logos of Cursor, Zed, Windsurf, AMP, Claude Code, and GitHub Copilot. And just because of how fast these things are moving right now, by the time I publish this video, it's likely there are 2 more logos that belong on this slide, and maybe one of these companies is already out of business. That's how fast these things are going, and that speed of evolution is one of the factors that makes this kind of technology really intimidating. It seems to work by magic. It's progressing faster than our ability to understand how it works. But the point of this blog post is that building a small and yet highly impressive agent doesn't even require elbow grease. You can do it in less than 400 lines of code, says Thorsten, most of which is boilerplate. I'm going to show you how right now. We're going to write some code together and go from 0 lines of code to, oh wow, this is a game changer. And so the blog post invites us to get our pencils out and to follow along, and it starts by creating a new Go project. Now, this is where it presented a bit of a speed bump to me, because Go is not a language I know well, or really even at all. I mean, I know what it is, I know what it looks like. I've never used it to build anything. So casually using it to explore a new technology would be like placing a challenge in front of a challenge. And so looking at this, I thought, you know what? I am going to try to follow along in a language that I do know well, which for today's purposes will be JavaScript written in TypeScript. And so that's what I've done. With this talk, I have translated Thorsten's blog post, which is excellent, but I've changed all of the code into TypeScript for an audience that knows that language well. So let's get started. This is the index.js file, the startup file for a Node.js command line app. It has a main function here, and the first thing that function does when it starts up is it creates a client for the Anthropic Vertex service. So Anthropic is the company that makes the Claude LLM models, and Vertex is Google's hosting of LLM models. It's its service for providing access to LLM models. So the Anthropic Vertex client lets me use the Anthropic models on the Google Vertex service. This happens to be the most convenient way for me to access a Claude model programmatically at CultureAmp, because we use Google Vertex to host our models for development purposes. I specify the project ID and the region, and it will get my credentials from the environment. But basically, I have created a connection to the Anthropic LLM model here as a client, and then I pass that client along with 2 other things to this agent object or class. This is a class that we are going to create. It is the body of our program, and we are going to instantiate that class. And then on the resulting agent object, we are going to call the run method. So this agent class takes 3 things: the Anthropic client that we've provided, a get user message function, and a show agent message function. So get user message is over here on the right here. It is doing some pretty standard Node.js stuff to present a prompt to the user with some nice shell colors there. And when the user types a message and hits enter, it will get that in this user message string, which it will return. And the show agent message is really just a console log, again, using some escape sequences here to present responses from Claude in a nicely colored header. So we pass those three things into the agent and then we run it. So let's look at the agent. This is our agent.ts file. It is, as promised, a TypeScript class with a constructor that takes those three things, the client, the get user message, the show agent message, and then it will have a run method, which to begin with just says to do. So what are we going to make this agent do? Well, the first thing we want to make it do is to provide a chat experience. So this is how we will give our agent instructions and receive feedback back from that agent. So we would like, for example, to say, "Hi, Claude, my name is Kevin," and have it send that up to the Claude model. And the Claude model might reply with a message that we want to present on screen. "Hello, Kevin. It's nice to meet you. How are you doing today? Is there something I can help you with?" And then we might respond with, "What's my name?" just to test if it's paying attention. But out of the box, it might say something like, "I don't have access to your personal information, including your name, unless you've shared it with me in our conversation." And this will happen because all of these LLM services are completely stateless. So every request you send to it is completely separate. It has no memory from one request to the next. As web developers, this should be familiar. This is how web servers work by default as well. So if we want to carry on a conversation, we are going to need to provide it some way to remember the conversation so far. And so what we do instead, to prevent it from saying "new phone, who this," is when we send our first message and it replies back, we will take that reply into a record of the conversation so far. So this is a reminder. You said this. And now I'm going to ask this follow-up question. And when we send this question to the LLM, we actually send the entire conversation so far as a list of messages. And then it is able to reply, "Your name is Kevin," as you mentioned in your introduction. This is how all LLM-powered chat experiences work. The longer you chat with them, the more context you need to send, the larger the record of the conversation so far gets every time you send it with your next message. And this is one reason why chats get more and more expensive in the number of tokens they use the longer that they run. So how do we implement this back and forth in our run function? Well, we will start by creating this conversation list. So it will be an empty array of Anthropic messages. So it's empty because the conversation has yet to begin. We'll display an introductory message saying Control-C to quit, and then we go into this while true block. So while true loop will just run over and over again until the user exits the program with Control-C. We will then begin by getting the user's first message using that get user message method that we passed into the constructor. And when we get that message, we will bundle it up into this object with a role user and the content of the message. This is what these Anthropic messages need to look like, and we will push it into the conversation. The conversation will begin with the user's first message. We then pass the entire conversation into this run inference method, which we have implemented over here on the right. It's a very short method. All it does is send the conversation in its entirety to the Claude model using the client that was passed into the constructor. We specify Claude 3.7 Sonnet here, and we say that we want it to reply with a maximum of 1,024 tokens. That will result in a response from the LLM, which we receive over here in our while loop. We push that response. First of all, we translate it into that same message param object format, which we do with this message to message param function over here on the right. Nothing too complicated going on there. And then we push that into our conversation. Our conversation now includes our request and the initial response. We then go through the messages in the response and look for any that are a text message from the LLM. And any text messages that we get from the LLM, we will display to the user with show agent message, that function that was passed into our agent's constructor with the message text. And that's it. We then start the while loop over again by asking the user to contribute another message to the conversation. And on it goes. Let's demo this. So I've got all of this code so far in this in my project here, and I'm going to run it with pnpm agent. Now let's say my name is Kevin Yank. It creates that conversation list, sends it to the LLM, receives the response, adds the response to the conversation, and then displays it on the screen. Hi, Kevin Yank. Nice to meet you. Okay, great. Now let's test if it remembers my name. I'll ask it to suggest some nicknames for me. Just a little risky. Let's see what it comes up with. All right, there we go. Vinny. Vinny. That's a new one. No one has ever called me Vinny. Okay. Yeah, interesting. Okay, let's move on from that very swiftly. And the blog post says, okay, let's move on because the nicknames suck. They do indeed. And this is not an agent yet. What is an agent? Here is Thorsten's definition: an LLM with access to tools, giving it the ability to modify something outside the context window. The context window is the technical name for that conversation list. It is the window of things that we will remind the LLM of every time we send it a request. Right now, all the LLM is empowered to do is to contribute messages to that list. So giving it tools that let it do other things is how we will turn it into an agent. So let's think about our first tool. What is a tool? Well, it says the basic idea is this. You send a prompt to the model that says it should reply in a certain way if it wants to use a tool. Then you, as the receiver of that message, use the tool by executing it and replying with the result. That's it. Everything else we'll see is just an abstraction on top of this concept. So replaying this in our diagram of the conversation, we might start the conversation by saying, in the following conversation, let me know if you want to use one of these tools. And then we list all the tools that are available. Then blah, 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 we have the conversation. And at a certain point, the LLM may reply with, I want to use this tool. In which case, as usual, we record that as a message in the conversation. We then follow its request. We run the tool for it and add the response or the result of running that tool to the conversation. We then send the conversation back to the LLM as usual, and it will continue with the knowledge of what resulted from its tool call. That's it. In his blog post, Thorsten says this is like when you're talking to a human, you might say, in the following conversation, wink if you want me to raise my arm. And in a funny sort of way, you have now given that other human the power to raise your arm. They can't literally raise your arm, but they can ask you to, and you will do it for them. And that is how an agent works. We tell the LLM some things we are willing to do for it, and then it will let us know when it wants us to do those things. So we can actually demonstrate this with the code we've already written. So back in our conversation about the nicknames, I'm going to say, when I ask you about the weather in a given location, I want you to reply with get weather location name. I will then tell you what the weather in that location is. Understood? So we're teaching it about a tool. It says, I understand. So let's try it out. What's the weather in Melbourne, Australia? That's where I happen to be, on the land of the Wurundjeri Woiwurrung people. It says get weather, so it is actually sending us a tool call. So we would now go to the Bureau of Meteorology website, look up the weather, and respond. It's sunny and 15 degrees C. Thank you for letting me know. Sunny and 15 degrees Celsius in Melbourne, Australia sounds quite pleasant. A nice mild day with sunshine. That's sweater weather, but comfortable. Anyway, it goes on. It asked us to look up the answer to the question we asked it. We looked up the answer for it. It then repeated that answer because it now has that knowledge. That is how a tool works in an AI agent. Thorsten in his blog post says that worked very well on first try, didn't it? These models are trained and fine-tuned to use tools, and they're very eager to do so. By now in 2025, they kind of know that they don't know everything and can use tools to get more information. Of course, that's not precisely what's going on, but it's a good enough explanation for now. To summarize, all there is to tools and tool use are two things. You tell the model what tools are available, then when the model wants to execute the tool, it tells you, you execute the tool and send the response up. To make step one easier, the big model providers have built-in APIs to send tool definitions along with your requests. So let's actually build a tool in our code. This will be the read file tool. And in order to define the read file tool, we're going to use the types that the Anthropic SDK suggests. But keep in mind, under the hood, this will all end up as strings that are sent to the model. It's all wink if you want me to use read file. So the first thing we'll do is, because this is a TypeScript program, we will write a type that defines what a tool definition is. A tool is defined by three things: a name, which is a string, a description, the instructions for what that tool does and when the model should use it, and an input schema. This is a schema that says what arguments or parameters are required when sending a request to run this tool. And the last thing is the function. That's not there for the LLM, that's there for us. When the LLM asks us to run this tool, this is the function that we will call to do the work for it. It will return either a string or a promise of a future string if it needs to do anything asynchronous. So then in our agent, we will add a couple of things to the constructor. We will have a show tool message. This is something that we will call when we are, when the LLM sends us a message to run a tool. And finally, a list of tools, which is an array of these tool definition objects. Our run inference function that we use to send requests to the LLM gets a little bit bigger. Before we were just sending the conversation, but now we are also sending this list of tools. And that list of tools we build up by taking our list of tool definitions and basically stripping off those functions, which I mentioned are just for us to use. We're passing along just the name, the description, and the input schema. Those three things are all that the model needs to know about to use our tools. Now, in our main function at the top of our program, we need to pass these two new things, show tool message and tools, to the agent constructor. The show tool message is just another console log function over here that provides some nice formatting in a different color. And the list of tools we are importing from another file that looks like this. This is just an export of an array with one item in it, so we have only one tool so far. It is the read file tool that, again, we import from another file. And now we're ready to actually write that tool. Here's what it looks like. There is not very much code here. It is just a big object with those fields we described: the name, read file, the description, which is the instructions to the LLM, the input schema, which says that there is a path argument that is required. It is a string, which is the relative path of a file in the working directory. And then over on the right-hand side is our function. This func, again, is the thing that we will call when we need to do the work of this tool. And its contents is really just plain Node.js file system stuff. We check if the file exists here with exist sync. And if it does, we read the file as a UTF-8 text file and return its contents as a string. That's it. That's our tool for reading file contents. So with that code added to our project, let's try it out. I'm going to check out this version and run the agent and ask it, what's in source agent.ts? which is that top-level file with the main function in it. I'll check the contents of the file for you, and then nothing happens. Do you know why nothing happens? Well, the LLM is winking at us, but we are not yet paying attention to winks. So back in our code, there's something more we need to add here. This is our run function for the agent, and inside of our while loop, we were previously responding to text messages by showing an agent message on the screen. There's now a second kind of message that we need to recognize from the model, and that's a tool use message. And when that kind of message comes in, we will call our execute tool method that I'll show you on the next slide. We pass in the request to execute a tool and get a result back. That result we will push into a tool results array. And then after processing all the messages from the LLM, if there are any tool results, then we can skip prompting the user for the next message, because the next message that we want to send to the LLM is the result of running the tool. We don't need to also prompt the user to type something in. We push all of the tool results into the conversation list and go back to the start of the while loop. That's it. That's everything that's changed here. Now let's look at the execute tool method. What it does is it looks through our list of tools to find the one with a name that matches the one requested by the model. If it doesn't find such a tool, we will respond with this error object that the language model will recognize. But if we do find the tool that was requested, then we create a string here to describe the tool request and show it on the screen to the user. And then the last thing we do is actually call the tool function with the provided inputs and put its result in this content field of this object, which is a tool result object that will go into the conversation record and be sent back to the LLM. All right. Our missing pieces are in place now. Let's try the demo again. Oh, and before I ask it to do something, I'm going to set something up here. This is a fun little thing that Thorsten has in his blog post. He is going to create a secret file .txt file on my hard drive. And it contains a riddle. What animal is the most disagreeable because it always says nay? Now let's run the agent and ask it, Claude, buddy, help me solve the riddle in the secret file .txt file. It is going to read the file. And there you go. It reads the riddle and comes up with the answer. The answer to this riddle is a horse. And at this point, Thorsten invites us to say, holy crap. In fact, he uses slightly spicier language in the blog post. Let's take a deep breath and say it together. Ready? Here we go. Holy shit. You just give it a tool and it uses it when it thinks it'll help solve the task. Remember, we didn't say anything about if a user asks you about a file, read the file. We also didn't say if something looks like a file name, figure out how to read it. No, none of that. We say, help me solve the thing in this file, and Claude realizes that it can read the file to answer that, and off it goes. At this point, I got a little freaked out because I realized this program was giving access to read any file on my hard drive to this language model that I maybe shouldn't trust. And so I'm going to take a slight detour here from Thorsten's blog post and talk about human in the loop. I want to approve all of these tool calls because already they are doing something potentially dangerous that I want to make sure seems sensible to me. So instead of the show tool use function, we are going to pass to our agent a get tool consent function, which is a little more strenuous. Instead of just doing a console log, it is going to ask the user, here's the tool request. Do you want to continue? Hit type yes or hit enter to continue. And if the user does anything other than hit enter or type yes, we will refuse to run the tool. That's what this looks like here in our execute tool method. If the user doesn't give tool consent, we return a tool result that's an error saying the user did not consent to tool execution. All right, so let us see how this works. Claude, help me solve the riddle in the secret file.txt file. Now this time, instead of just going ahead and reading it, taking liberties, it actually asks if I want to continue. And I can say no. And my refusal goes back as a part of the conversation. And the model actually deals with this pretty well. It says, I'm unable to access the file because I need your consent. Would you like me to read this file for you? If so, please confirm that I have your permission and I'll help you solve the riddle inside. So this is working great. Okay, I'm feeling more comfortable again. We can go back to the blog post. The next thing Thorsten invites us to do is to create a list files tool. If you're anything like me, he says the first thing you do when you log into a new computer is to get your bearings by running ls, list files. Let's let our agent do that. We add a second file to our list of files here, and we import that from a separate file and add it to our array. And then this is what that tool looks like. It's pretty much like the last one. There's just a little more code because listing directories in Node.js is a little less convenient. But we have a name, a description, an input schema that requires a path, although the path is not required this time. It's optional. We say in the instructions that if you don't pass a path, we'll list the current directory, which is a nice convenience. And then over in the function on the right-hand side, we check if the path exists and is a directory. And if so, we iterate through all of the entries. But the one little extra we do here is that if an entry is a directory, we will output it with a slash on the end, so that we provide a little clue here to the model of which things in the directory are subdirectories or not. And that seems to work really well. So let's go ahead and demo this. What do you see in this directory? We'll ask it. I'll check what files and directories are present, and it calls list files with no arguments, just as it should. And there you go. It is reading my directories, and it says this appears to be a TypeScript JavaScript project using PNPM as a package manager with a DevBox development environment set up. There's also a file named secretfile.txt, which might contain sensitive information. There you go. It's done a pretty good job. How about tell me about all the TypeScript files in this project? It is guessing there might be TypeScript files in the source directory, which is a pretty good guess. And there's a subdirectory called agent with my agent class in it. And there's a subdirectory called tools with all of my tool definitions in it. It's scanning all of those. And now it's requesting to read each of the files that it's found in there. And it's this point that I start second guessing my caution of requiring an approval for every single tool call. But better safe than sorry. And finally, there we go. A great big project overview. This is a TypeScript project that implements a Claude AI agent with tool calling capabilities. It creates an interactive command line interface where users can chat with Claude and allow it to execute specific tools. And it's got a breakdown of what happens in each of the files. Really good. Pretty neat. Let's try one more thing. What TypeScript version are we using in this project? What would you do if you were asked that question? Well, you would probably go and look in the package.json file, which is exactly what it does. It finds my TypeScript dependency. Ooh, it's also going to read my tsconfig file in this case. I guess it's curious about my TypeScript configuration, not just the version. Yeah, wow. So It's gone above and beyond here. It's identified TypeScript 5.7.3, and it's further analyzed my TypeScript configuration settings. Nice work. Okay, so there we go, using the two tools together. Now let's let it edit files. The last tool we're going to add is Edit File, a tool that lets Claude edit files. Holy shit, you're thinking now? This is where the rubber hits the road. This is where he pulls the rabbit out of the hat. Well, let's see, shall we? We create a new Edit File tool. And here's the structure of this file. We'll say that it's a tool that lets you make edits to a text file. It replaces old string with new string in the given file. Old string and new string must be different from each other. If the file specified with the path doesn't exist, it will be created. And then on the right, we check that old string and new string are different. And if they are, then we will attempt to edit the file. I've put the code for that on a separate slide because it's a little too long to fit. So we will check if the file with the given path exists. And if so, we make sure that the old string is not empty. We then read the contents of the file, find every occurrence of old string and replace it with new string, and return a string that summarizes what we've done by counting the number of replacements. If the file didn't exist and old string is empty, then we create a new file with new string as the contents. And if none of those things happen, then we throw an error because we are trying to edit a file that doesn't exist. That's it. That's our editing tool. Let's demo it. I'm going to copy and paste this next one to spare you watching me write it. Hey, Claude, create fizzbuzz.js that I can run with Node.js, and that has fizzbuzz in it and executes it. This is a pretty typical interview question for programmers. There is the implementation of fizzbuzz in JavaScript that it wants to write into a fizzbuzz.js file. Looks good to me. Now, if you don't know fizzbuzz, it has described it up there, what it does. Multiples of 3 will be output as fizz, multiples of 5 as buzz, multiples of both as fizzbuzz. Otherwise, it'll just output the numbers. Yes, we will let it read the file to confirm that it was created correctly. And it reckons it's all done. It even tells me how to run it. So let's accept the invitation. There we go, a working fizzbuzz. There's more to try though. Let's actually edit this file. That fizzbuzz to 100 is a little long. Please edit fizzbuzz.js so that it only prints until 15. That should fit on the screen. It's going to list the files in the directory to make sure that file is there. It's going to read it. It's going to edit it. There we go. It's used all 3 of our tools. It's going to edit it again to make another change. And it thinks it's done. Let's see if it's right. There we go, a working fizzbuzz from 1 to 15. Let's do one more. In this one, from Thorsten, we're going to ask it to create a congrats.js script that rot13 decodes this string and prints it. If you don't know rot13, it's a very weak encryption algorithm that just shifts every letter in the alphabet by 13 spaces in order to make an indecipherable string. That's exactly what it's going to do in the JavaScript code. So let's exit and node congrats.js. Congratulations on building a code editing agent. So there we go. At the end of this article, it says, isn't this amazing? If you're anything like all the engineers I've talked to in the past few months, chances are that while reading this, you have been waiting for the rabbit to be pulled out of the hat, for me to say, well, in reality, it's much, much harder than this. But it's not. This is essentially all there is to the inner loop of a code editing agent. Sure, integrating it into your editor, tweaking the system prompt, giving it the right feedback at the right time, a nice UI around it, better tooling around the tools, support for multiple agents, and so on. We've built all of that in AMP, but it didn't require moments of genius. All that was required was practical engineering and elbow grease. These models are incredibly powerful now. 300 lines of code. It's more like 400 in Node.js for the record. And 3 tools, and now you're able to talk to an alien intelligence that edits your code. If you think, well, but we didn't really, go ahead and try it. Go and see how far you can get with this. I bet it's a lot farther than you think. That's why we think everything's changing. If you want to take this project for a spin, you can find the link to the GitHub project with the source code in the description of this video or in the blog post where you're viewing it. And if you want to read the original article, I invite you to go and visit the AMP Code blog. So there you go. The blog post of the year for 2025. I can't say I disagree, and I'm happy it exists in TypeScript now. Hope you enjoyed it. Thanks for watching.